Today I'm going to build a circuit from 7.1 for an AC analysis of a ZVN3310F. I don't have the exact transistor up here, but this is another NMOS. So this should function very similarly. So now I'm going to build the circuit. I'm going to set this to 68 ohms and the other one to 470 ohms. Kilo ohms. Duplicate this one. Get 1,000,000 ohms. Oh, I want to clone it. There you go. I'm going to tie these together and then tie these together. Oh. I'm going to tie these together. I'm going to add the capacitors. Ground here. I don't have the polarized one, so that might be difficult. Okay. This one was 10 nanofarads. It's kind of hard to build from memory. And now I need to connect this. Come on. And this goes to ground. And this is connected here. This and this go to ground. And the 5 volts goes in here. Voltage. There you go. I'm gonna redraw that trace because that one looked funny. Go. Oh, cool, it works. Okay. So basically this is oscillating between 4.3 volts and 3.4 volts in AC. It's not graphing it. I don't know why it doesn't do AC for some reason. The other graph in the teacher's video did AC. This should generate AC somewhere, but it's not, so that's really annoying. But it should generate an AC. If you want to increase the AC voltage, you would decrease this resistor here. And you increase the voltage. See how it kind of behaves where it increase. So it will give an oscillation eventually. These capacitors affect how fast that oscillation happens at. This is a lot of nanofarads. I'm going to change the current again. It's dropping, but if you increase the value of the capacitor, it'll take longer to drop and increase. So now I put it back, it's not doing anything. Stop it and run it, it'll do that, but then if I drop it, the capacitor has so much stored energy in there. It's going to take a while for it to drop. So that's weird. I'm curious if this one affects it. I didn't really do math for that one. Not as much. So again, that's what this can do. I use for this, I guess, you could use this to amplify a signal because it can make AC current. You could amplify it with this device by having high resistance on the end and low at the beginning of it. Not much else I can think of. Oh, cool, it moves. Well, that's all I got. I would build this in mutualism, but if you want to make this in waveforms as a physical circuit, you can you set up a power supply of 5 volts and you build this circuit in this way as the teacher has it. Pull that up real quick. Like this here where all the capacitors connect to the resistors. It actually looks a lot simpler as a circuit than it does as a schematic. That's how you connect it, and then the 2 green wires on the right and left, you would hook the positive and negative up to that, and that would start your circuit. And you take measurements from the transistor emitter base and what's the run and the output, and then you have your voltages. And it should match this. This is the graph it should make. I don't know if those lines are visible, but it should oscillate. But see how it doesn't oscillate all the way down? There's a second wave function that's just a little bit lower than the first one. That would be this guy right here. This green one's the higher one. And that's the end of this video. Have a good day.